Hello, dear students, and welcome to this section, which is about writing shell scripts. Now, before diving into writing shell scripts and learning all the ins and outs of shell scripts, there are a few things that I want you to learn about before diving into writing these shell scripts. Because these will be um, the line between being very good at writing shell scripts and being very bad at writing shell scripts, because they are like very important concept to understand and have a good understanding of. So here you can see I have opened my terminal, and the first thing I want to do, I want to create a file so we can use this to just write some notes and stuff like that. Now, first thing I want to talk to you is um, kernel shell, right? And application user, and here we want hardware, right? Now your PC is a hardware, right? Contains all these chips, wires, and so on, hard disk, CPU, RAMs, and so on. What manages all of these is the kernel. And here we are talking about Linux, not any other operating system. The kernel manages all these hardwares and interface between this hardware and your shell and your application. All right. So, for example, here my terminal, like this one, this is an application, and this application runs inside the kernel. So it uses the APIs provided by the kernel, so it can run. And basically this application is a code, binary code, that is the kernel is responsible for managing it in terms of rendering it on the screen, for example, doing all these actions. So for example, if you press on any button here or any menu, the kernel will take this command and understand this is what you are going for. So it will instruct the hardware to render these options for you, make your mouse work with them, and so on. All right. We don't need to go deeper than that. It's just as simple as that. And the shell is considered as part of the kernel and part of the application. So it comes between the two. Any application, including GUI applications, user interfaces, these are considered shells, all right? And not the application itself, the application here it is, but the shell is basically the part, the code that is responsible for rendering the user interface, like GNOME and KDE. And I know I did not talk about these, but these are user interface management systems in Linux. So they are responsible for all these windows you get, these icons, and so on, the behavior, the look and feel of your environment here. All right. So shells comes with multiple types. Some of them are user interface based, like GNOME and KDE, and some of them are text based, like if we open a new tab here and type cat etc shells, we get all these different shells. All right. And the one we are using by default is Z shell, right? So if I type echo 0, I get the shell that I am currently using, which is Z shell. This is the one used by default in Kali Linux. So going back here, we said some of them text-based, some of them user interface-based. So this shell is what sits between the application and the kernel, right? So that's why we consider it sometimes as part of the kernel, sometimes as part of the application, because the shell itself is sometimes an application in itself. All right. So these different shells you have, and you can use any of these, like out of the box. You can use change to these shell environments and use any one of them. And the way you do that, but just by typing the name of the shell. So for example, I want to use sh, and now if I echo 0, you can see I am using sh. Maybe I want to change to dash. If I echo 0, I can see dash, but I want to use zsh, right? And I don't want to clear that, keep everything here. And as you can see, Kali Linux now supports Microsoft PowerShell, which is this one, Windows PowerShell. All right, it's the improved version of the command prompt, which is this one. All right. Anyway, so by default, you can run inside Kali Linux Windows PowerShell script, but this is not what we are here to learn about. Going back here, so the application is what you use to do actions. For example, all the commands we learned about in previous section, like for example, pwd, this is an application, cd, this is an application, apt, this is an application. All of these are applications that the shell can understand, convert them to a form that the kernel can understand, and as a result, you can think of the shell as a management code software for interfacing the application with the operating system, so that the operating system can understand this application and run it and make all your hardware run smoothly with your application. So it will manage, if your application requires sound, your kernel will make sure that your application have access and can talk to the speaker or microphone. If it requires rendering images, it will make sure that your application can access the screen and render correctly the images, videos, and so on, whatever you want, basically. All right. So finally, you have the user, which is you, me, anyone who is using this application, because the way you interact with your operating system is through applications, whether you are using user interface based applications or text based application, doesn't matter. You interact through applications. So having that being said, when you write a shell script, right, you are basically writing a file that contains all your commands, your instructions, and sending them to the shell, and the shell will manage everything inside and send that to the kernel. So if we go back here, you can see we have many shells, right? And the reason I told you that we have many shells, because we are writing shell script, right? So when we write a shell script, we need to tell Linux, all right, which shell to use, all right. And the way we do that, assuming this is a shell script, so let's delete everything here. The first line of code will be called the shebang, all right, because it starts with sharp and bang, or exclamation mark. We use etc. Then basically we are providing the path for the shell. So since here we are using z shell, right? So what we'll do is go back, user bin shell. We need to provide this path. So user, keep forgetting, bin zsh, right? And now the shell, once you pass this file to the shell to execute it, it will look for this and know which shell to use, so in order for the shell to be executed successfully, because different shells have support for different applications. Even when you install an application using a specific shell, it will not be, generally speaking, accessible by other shells. So it's very important if you want to use something like you install, like maybe you have installed Wireshark, Mmap, any other software that you wish from the internet. You want to use that inside a shell script to do some action for automation. Maybe you want the shell to know that this file exists. That's why you need to specify which shell you are going to use. All right, and after that, right, we add comments. Now comments start with right, I don't want to do that. All right, just Ctrl X. All right, comments start with a sharp or hashtag if you wish, and do notice that this means this is also a comment. All right, but this is a special comment here. And comments should make like a documentation of the script. So you should here add things like owner, all right, who created this script. Keep just doing this anyway. Also maybe creation date and the purpose of the script. All right, and yeah, basically these are the basic informations, and you also need to add modification date, and these are very important so that you remember. If you forget what this script is about, you always have this information at hand. All right, the next thing in a shell script, we add variables. We'll talk about variables, don't worry about that, but here we are learning about the general structure of a Linux shell script. So variable, right, any variables, you put them at the top, then the logic. So basically any if statements, while loops, functions, and so on. All right, so this is the basic structure of Linux shell script. Now, having that being said, let's before I forget, when you write shell scripts, and we will write a lot of them in this course, put them all inside a specific folder. Don't just put them anywhere. And the reason for that is basically for just management, right? You don't forget where you put them and it will be like a mess. Just have a specific folder where you have all these shell scripts. And the reason for that, let's come back to the second part, which is, let me save, right, Control O, and I will name this .zsh. And the reason for that is, so you remember by just looking at the name of the file, right, that this script should use zsh. So this is not for the shell, this is for you, right? And here the name of the shell script should be meaningful, should indicate what this script is going to do. Maybe, for example, this is for scanning a network. So what we name this, maybe scan network. Now hit enter. save file under different name. Yes, and we are done. Let's exit, list everything, and here is scan network.zsh. Let's cat that, right? And you notice here spaces are generally not allowed. That's why we should use escape character for that space, all right, to indicate that this is one name together, right? Because otherwise, if you don't have this, all right, it will understand that cat will think that this is a file and this is another file, and it will try to open these two files, but these two files will not be there, so they don't exist, and you'll get an error. But this is one file name, so you should add before spaces and file names escape character, which is backward slash. All right, so here let me make directory. I will call this script, or actually let me make that inside documents scripts. All right, and let's move scan networks to documents scripts. As you can see, it's gone. So let's go to documents scripts. Now we are there, and let's do list. Here it is. Let's do nano, right, and scan networks.z shell, and inside here I will just type echo zero. So echo 0 as this, control O, enter, control X. I told you that we need to put them all inside a script, and here's why. When you want to execute a script, this is what you're going to do. Add period, / then script name. Don't want them two, one in it is enough. And run, and you can see now permission denied. So what you need to do is change mode, because this needs to be executable in order for it to be executed. So change mode, maybe all add execution mode, scan the network.chill. Now we have that. Now we can run this, and it's not working. Let me check why. Going back here, let's try echo something else. Right, let's echo hello world. Let's do that one more time, and we get this output. All right. Now, if I do directly scan, scan that image, right, scan network, as you can see, it cannot identify this file to run this. So in order for Linux to understand this file should be executed, we should provide a path for the file. So if it's if the name of the file is part of a path, it will understand this is a shell script. And so basically here we are inside the scripts folder. What we are doing here, we are providing a pseudo path basically, right? And the pseudo path is, if you remember, a period refers to a folder, which is this folder, right? The folder that we are in, and then the name / and then the name of the file, so that shell or this terminal here understand this is a shell script and it should be executed, right? And we can execute that. And you can do that if you are outside. So maybe like you are here, what you can do is now say documents. Sorry for that, I don't want this, right? Can say period documents. Why is it not working? So let's add a relative path. This is called a relative path. Documents. Actually it's this current path, so it will be scripts. I forget that we are inside the documents. I thought we are outside the documents. That's why I'm getting these stupid mistakes. Anyway, so period refers to the current path we are in, which is documents, then scripts, then script name. And now we can run. Or what we can do also is start from the very beginning. So home, Kali, documents, all right, then scripts, then file name. Hit enter. So we can add or use a relative path, or we can use absolute path basically. I think that would be all, generally speaking. Yep. Let me just check very quickly. How long are we? 21 minutes. Oh my god. Okay, I think this is enough, more than enough actually. In the next video, we'll start learning about writing shell scripts.